Hi everyone. In today's lesson, we're going to talk more about motion of a line, part two, but this time we're going to talk more about displacement and distance. So the first thing says here, it says a particle moves along a horizontal line according to the standard position function x of t. Its velocity function is given as such for when time is greater than or equal to 0. So part A says to find the standard position function x of t when x of -1 equals 6. Now, we've been doing this for the past two videos. So what I'd actually like you to do now is pause the video and try this part on your own and then hit resume and then the answer will appear. All right, this is what I got. So take a minute if you need to and pause the video and take a look at my steps. If you have any questions on this, please feel free to ask me tomorrow in class. I'm just going to assume that we all know that this is what my x of t function is, and I'm going to move on with the rest of the problem. Okay, so the question's now asking us to find the total displacement over the first 10 seconds. And if we remember, displacement is just when we plug in x of b minus x of a, where my interval is from a to b. So since I'm asking for the first 10 seconds, that just means I want from the interval from 0 to 10. So 0 is going to be my a, and b is going to be 10. So if I want to find the displacement, all I simply have to do is x of b minus x of a, and we said b is 10 and a is 0. So take a minute, go into your x of t function, the function we just found, plug in 10, plug in 0, and then subtract. So take a minute to actually do that, pause the video, and then hit resume when you're ready for the answer. Okay, so for x of 10, you should have gotten 215. And for x of 0, you should have gotten 175. And when you subtract these values, you should get 40. So we have a displacement of 40. Now remember, since displacement here is positive, that means we ended up 40 units to the right of where we left off. So if you want to write that down, 40 units to the right of where we started. If displacement was negative, then we would have said 40 units to the left of where we started. And I'll show you visually what this means once we do the distance in a second. Okay, so now let's do the distance. So I put the steps here for us. We did this originally, when we did motion part one. So I'm going to use them as we need. But the directions say find the total distance over that same time period from 0 to 10. So we first have to find where v of t equals 0. This is where the particle is going to change direction. We need this in order to add up our distances. So we need to set v of t equal to 0. So first, we actually need to find v of t. So I'm actually going to write down our x of t function, and that was t to the third minus 24 t squared plus 144t plus 175. That's what we just found on the previous page. So v of t we know is the derivative of this. So take the power, bring it in front. We've got 3t squared minus, don't forget, take this power, multiply it in front, 48, decrease the power by 1. The derivative of 144t is just 144, and the derivative of a constant is 0. So I believe we've used this, yesterday and the day before when we did our motion part 2 videos. So I'm just going to go through it quickly. So v of t would be 0. Take out a GCF of 3. We are left with t squared minus 16t plus 48. And then when we factor by add multiply, you should be getting negative 12 and negative 4, which then gives me 12 and 4. So these are the values where we change direction. And these values are extremely helpful for us because we need to use these values along with the endpoint of the interval for the 10 seconds. So from 0 to 10 is my interval, right? So these values, I'll highlight it here so you have them. So the value of 12, 4, 0, and 10 need to go on a chart. But more specifically, they need to go on our x of t chart or our distance. So we've got t, and then we have x of t. And the values that go in for time are simply going to be my 0, my 10, because those are the endpoints of this interval. And then we have to put in here where it's changing direction, so 4 and 12. But we're really only going to put the 4. We're not going to put the 12 because the 12 is outside of that interval. So the interval that I'm asking for is only the interval from 0 to 10. So we need to reject this 12, and you can put reject, and you can write because it's not in the interval from 0 to 10. If it was in that interval, then we can include it. So really the only values that I care about are the 0, the 4, and the 10. The 0 is my A value of the interval, the 10 is the B value of the interval, and the 4 is where it's changing direction. So what we have to make sure we do now is go to our calculator and put into our y equals this x of t function, right? Because this is an x of t. The standard position will give us distance. So you're going to take a minute, pause the video, and you're going to type this into your y equals and tell me what these three values are, and then hit resume when you're ready for the answer. Okay, so when x is 0, you should have gotten 175. When x is 4, you should have gotten 431. When x was 10, you should have gotten 215. So if you remember, standard position gives us the values of where they are on the horizontal line. So 175, 431, and 215, these values here is where the particle is located on the line. Okay, so all these things are going to come together now, and we're going to draw our picture to get our distance. So here is my horizontal line, and these are the values of where they're located. So 175, 431, and 215. So we're going to put these in numerical order. So maybe, again, it doesn't matter where you put it, but like let's just say 175 is here, 215 is pretty close to it, and then maybe 431 is a little bit further away. So we know at time equals 0, I am located at 175. So I'm going to go ahead, put a little dot here, and put time equals 0. Then at time equals 4, another dot, I'm at 431. And then at time equals 10, I'm at 215. So over here, we'll put another dot, time equals 10. And we just have to make sure we connect them. I went right from here to here, and then I went left from here to here. So if I want to find the distance that this particle traveled, I just have to count. So from 175 to 431 is going to be one distance. And then from 431 to 215 is going to be another distance. We're just going to add them together. So all you simply have to do is subtract these two values to get this distance. So we're going to do 431 minus 175. Go ahead, type that into your calculator. Hit resume when you're ready. That should give you 256. So from here to here is 256. Then we're going to put in 431 to 215. So we'll go to our calculators again and do 431 minus 215. And you should get here 216. So that's the distance from there to there. And if I want to find the total distance that this particle traveled, all I need to do is add up those values. So total distance is simply going to be 256 plus 216. And that gives us 472. So this is my total distance traveled. Now, just to check displacement, we decided that, or in the first part of the problem on the first page, we said that the particle ended, right? It started here, ended here. It's ended 40 units to the right of where it started. So, I mean, that kind of makes sense, right? If it started here at 175 and then it ended here, what's the distance from 175 to 215. This distance is absolutely 40. Therefore, we're correct that my displacement was that I ended 40 units to the right of where I started. And that's it. All right. If you guys have any questions, now's a good time to jot them down and make sure you ask me in class tomorrow. All right. Have a good night.